We're officially recording now. Okay, well, I'll just start. People come in as time goes on, and I'm just reminded now that I kind of was supposed to do something about the Bing Bong, but never mind, which I admit that I completely forgot. Okay, this is the second in a series of workshops on data science soup to nuts. So the idea of the work, for those of you who haven't been to Dublin data science workshops before, the idea is that it's a bit more interactive. There's a bit of coding in it. It's not really kind of me lecturing, but I try to, get as much interactivity and going and show some code examples and talk about a bit of theory and be a bit more it's more teaching rather than presentation. The idea behind this series of work, usually I kind of pick a topic and it gets covered over 2-3 months, like over different sessions. We often used to do it in person, but now obviously in this COVID world, we've had to innovate. So I've done a few more and you'll find them online, but this one was kind of, the idea is it's going to be a full data science project from the very start to getting the data online and downloading it onto your computer, going the whole way through data exploration, figuring out what's there, trying to make some sense of the data, building some very simple models, trying to understand, what the models are telling us, what recommendations we can give, whatever kind of things there is to be communicating on, like basically coming up with that story to tell, and then presenting the data and presenting it. So that's the idea. That's the soup to nuts. It's an old English expression where full meals would start with a course and end with a nuts course as part of dessert. Like I said, I'm recording it, and because this is quite accessible and a bunch of people had been asking me about this, and I've been asked about recordings because we are doing them online. I've created a YouTube channel called Dublin Data Science. The first 2-hour session was recorded last month. That's online. Because I am recording this, it takes a little while to render. It'll probably be either tonight or tomorrow. I'll then look to upload it, and this one will be available there. And yeah, and that's kind of where we are. Okay. Now, just to ask in the chat, can people just tell me if you were at the first episode? I recognized a couple of names, all right, but you don't have to shout out or anything. Could I ask, probably also, it's probably worth people going on mute. Apart from it, just sometimes people log in and there's a bit of background noise. Great. Okay, a bit of a mix of everyone here. Some were here, some were not here. That's fine. That's grand. Usually what I do is, apart from the very first one, okay, that's hard to say exactly, but my extremely accurate polling data tells me that it's about 50-50. So, but that's fine. So just to let you know, what I usually do in these, I will summarize what was covered the last time, probably a bit more abbreviated. In this case, probably not as abbreviated as you would, because we kind of got data exploration started and we discussed some things in the data, but we're going to be going over that again. It's just the nature of this part of the process. So don't worry if you missed the first one. It's recorded online. If you really want to watch 2 hours, maybe put it on double speed. But also I'm going to kind of cover at least the Cliff Notes version of it here. Okay. Before we start, does anyone have any questions? Or is there anything from the last time or this time, or is there any issues with the sound or the screen size? Like, do I need to make it bigger, or anything like that? I've just increased the browser size to 150%, but I'm happy to change that if we need to. Let me just set my phone up here so I can see what I can see. And cool. Okay. I'm going to assume that's no questions, so let's just start. All right. So what we're working on here is a data set from the UCI machine learning repository. And just for those of you who are interested, I will show it because this is handy. Now, one of the things I did the last time was I did a bit of live coding. I'm not saying I won't do it today, but I'm going to try and minimize it a bit. So I kind of have a bit like a cooking show. I have some code that I've kind of used earlier that I'm going to be copy and pasting. I'd rather copy and paste and run the code live, because that's kind of gives people a feel for how this works in real life. What I'm trying to do with this whole series is, first of all, kind of demystify a lot of this stuff, because if you look at talks about machine learning and data science and AI and all this stuff online, it can come across as incredibly complicated, and that stuff tends to be. But that's a very small fraction of what the world is like. It's a bit like thinking, the way I always draw parallels to sport, because I love GA and soccer in particular when I was younger. It's a bit like assuming everyone playing football on the planet is like Lionel Messi or Cristiano Ronaldo. You know, they are the elite that everyone looks at, and that's kind of what really sophisticated AI models are like. The vast majority of the work is like Sunday league football. You know, it's just a bunch of people trying to do their best. They're not world class at anything, but that doesn't mean you can't get something done. And it in no way lessens, you know, the achievement. If your Sunday league side wins a cup final, that's great. You know, it doesn't mean that, you know, it's not worthwhile doing just because it isn't the Champions League. And I kind of feel that way about all this stuff. There's a whole lot of stuff that can be done that doesn't require really sophisticated stats or maths, doesn't require a whole lot of sophisticated programming, doesn't allow you know huge amounts of computation power and resources to get done. You know, some data sets just aren't. I mean, this is a relatively large data set, and it's only 1 million rows, which a home laptop can handle with ease these days. So that's kind of what I'm trying to show. So the data is on here. Hold on, retail. And it is the online retail too. There was one before this. This came out recently. It's about 1 million rows. It's basically a whole load of transactions. So we kind of get the basic idea of the data here. There's a URL we download it from. And the idea is it's transactions from all the transactions occurring for UK-based and registered non-store online retail between the 1st of December 2009 and the 9th of December 2011, so just over 2 years. The company sells unique all-occasion giftware. Many customers of the company are wholesalers. So this is basically, and then there's a bunch of data that it's on it. And why did I choose this? Well, I chose this for two reasons. One, we haven't really covered a whole load of retail in Dublin data science in the last couple of years, with one notable exception, a guy who spoke about his use on a retail set and how he explained explainable machine learning, which happened a few months before the lockdown, which was brilliant. And it's basically where an awful lot of this stuff is being done these days. Online retail and kind of e-commerce in general has been, you know, probably the main industry to fully embrace a lot of these techniques. And a lot of these techniques came out of it from either, you know, this or big tech companies or stuff like that. There's been a huge amount of success, you know, based around this. And, you know, they've got the benefit of the good, you know, the good data lakes and data system, you know, have presented and collected their data in a relatively same way. I just to give you a word of warning, I do have a big mug of tea here, which is going to help lubricate my voice. So you may hear some slurping sounds. I'll try and keep them to a minimum. But I am going to kind of sip away at it over the next 2 hours. So the plan for the thing is we're going to go through till about, it's sometime between say 10 to 8 and 10 past 8, depending on the flow and how we get on and whatever questions you have. We will take a break around then, because there's no point in just plowing on and going straight through. I'd rather give everyone a break, go to the bathroom, grab a cup of tea or whatever. So sometime between, depending on how we fall, like I said, 10 to 8, 10 past 8, ideally like 10 to 8. I'd rather, you know, break earlier. We'll take a short break, maybe 10 minutes. I'll also happily answer any questions in that period. And then when we come back, we'll do the second half, and then we'll go through to, you know, 8:45, 10 to 9, depending on who's around and what any types of questions you might have. Okay, right. So let's get started properly, because I've been blathering on for long enough. So the first thing we did last week, and I'm going to go very briefly over it, was we have a little routine here that actually downloads the data. So all of this is in our Markdown. I do most of my work in our Markdown because most of my work tends to be research in nature. And this stuff is kind of, there's no point in trying to quote unquote productionize any of this stuff, because you don't necessarily know what you're doing. It's quite exploratory. So this kind of becomes my like lab notebook. And it means if I'm making mistakes or whatever, I don't have to throw away a whole load of work. I can just kind of save the workbook and start again. and kind of plow through it. So I have a little workbook here, and all it does is it goes onto that URL that we looked at with the machine learning repository, and it just downloads the file. I have a little bit of logic in there to say, is the file downloaded already? And if it is, don't download it, otherwise do. Nice and simple, it saves it into the data folder. So it's an XLS file. And then we have a second piece of the routine, which reads in the file and then parses it in R using, read Excel and a couple of other bits and pieces, does the relevant, quantification, and then writes it as an RDS. And doesn't really do anything beyond, puts things in the format they kind of need to be in. Like, for example, there's this weird thing with Excel where date times are stored differently to the way a lot of other places create date times. So it's based on the 1st of January 1900, but it doesn't account for the leap year properly. So there's a bit of a weird stuff. It's basically the number of days from the 30th of December kind of solves the problem. So that's kind of, I put those things in there. We talked about this more last week in terms of why we're format CV and we just didn't use read Excel properly. It's just got to do with this kind of crappy, the read Excel is a bit crap. So in terms of getting the right data types on the columns and things like that. So what we do instead is we just read the data in and everything as a text, write it out as a CSV, and then read it back in with using readr, and that gives us all the proper column formatting. So that's what we've done there. So once we did that, then we switched over and we kind of started the process of doing some data exploration. So this is based on a template I have. The URL you can see there. It's on GitHub for any who want it. Basically, you read in the data, and the idea is it kind of goes down and does a bunch of stuff, and then it has these knit-r, knit-exit breakpoints. So the idea is these are uncommented at the start, and you run the code, and I use Glimpse a lot and a bunch of other things just to check if the data works properly and has it been read in, and do very simple things like, does the data have as many rows as you think it has? Now, I know this sounds really stupid, but I actually got caught on this one, because what I didn't realize when I downloaded the Excel file is I didn't open it in Excel. I just read it straight using readr, because I was like, I'll just use read Excel. What do I need? What do I need? A spreadsheet program. And then after a little while, I didn't check the row number, and I noticed there was only 500,000 rows. And it was at that point that I realized that the data was split into 2 tabs, one for each year. And what I really needed to do was basically read the data in from the 2 tabs. So the key to this is, always try and open the data in a relatively easy format. If it's an Excel file, just open it in Excel or a spread. Like I use LibreOffice because I don't have Excel because I don't really use it. But just open LibreOffice and just have a quick look. And that can often save you a lot of time in terms of just learning how to parse the data, learning how to figure out, what's there and what isn't. So what we do is we just pass this data down, and it renders into this R Markdown document. Now, I have made a mistake. Hold on. I need to change that. Hold on one second. Is that the other thing we had before? Because I was using RMD formats, and that it's generally nice. So it's not a big deal if but if I have it handy, I will fix it. And if not, I will fix it during the break. It's just a nice RMD format. Oh, let me just move these. It'd be faster if I have proper access. Sorry, I've got a second set of code here on my other screen. Yes. All right, let me just change that output. Let's just change this so we can pop that down to what we were kind of working on the last time. And just so everyone knows as well, I'm jumping across myself. We have all this in a GitHub repo. So if you go to GitHub, Kevin Roll, it's DDS soup to nuts. So that is the workshop that we're coding out of live today. So I've made a few pushes and pulls from like last month. You can see 28 days ago, which is when the last workshop was. But what I'll be doing today is whenever I make commits, I'll be making commits to this repo, and I'll be pushing up any commits that we make so that you can kind of track along in real time if you want as well. If you want to make a clone of this repo or whatever, that works fine. It all should work out fine. So yeah, so that's what we're kind of working off. I've also got this running in a Docker container, and I have a talk about that. For those of you who don't worry about it too much, we can kind of deal with it later. But yeah, that's kind of where we're at the moment. So first thing, what I tend to do is I just run our Markdown Render a lot in the browser. And the reason why I do that is because it kind of helps me, oops, the auto tab on this, the autocomplete is not the best. I type, so I'm going to render that. And the idea is, like I said, we've got these breakpoints so that we can just do the first chunk of code, just make sure the data has been read in properly. Like check things like how many rows are there, how many columns are there, does it look like the various types are correct? Does it look, you know, is there any obvious glaring errors? And it's amazing. First of all, when you're dealing with a random data set, always check that stuff because you have no idea what you're going to end up being handed, especially in older, more based enterprises. So if you're doing this based in like an old bank or a large retailer that have had IT systems around for like 20 or 30 years, you wouldn't believe the nonsense that can get outputted as part of the database dumps. You know, like I have heard, I remember my favorite one was a file that was something like 8 gigs in size. And whenever they opened the file, it was empty. And it was based on like user-based input, but somehow it was an empty file that someone had put in the null character, and 8 gigs worth of null characters got added in. So when you open the file, it looked empty because it was 8 gigs worth of null characters. But when you looked at how much space it used on the disk, it was 8 gigs in size. And that caused quite a lot of consternation and a few days of wasted effort trying to figure out what the hell went wrong there. So, you know, just always check, like, there's no test so simple. Oh, whoops, sorry. If I've asked anyone to unmute, my apologies. Let me just mute everyone. There we go. All right, can everyone hear me? Yeah, so like there's no amount of stupid checks you can make. You know, don't be too afraid that something's just too simple, because in my experience, you know, it's probably worth doing because, you know, these things do happen. Yeah, there we go. This is a much nicer format. This comes off a package called RMD formats, and I just think it has a better, it just has a better look. So we're going through the data here. So these are just values we won't worry. So we've read in the data. So we've got about 1 million rows, which is what we heard anecdotally, and we've got 8 columns. So looking at it, you can see the invoice is a character, the stock code is a character, the description is a character field, the quantity is numeric. Yeah, it could be an integer either, but it's done it as a double. Probably better as a double because it's just easier. Invoice date is a number, which is a bit weird. And then the price is a number. Okay, so there's obviously the invoice date we didn't fix, so we need to. So that's fine. And then this customer ID is also a character. And then there's a country as well, which is the United Kingdom. So we're going to clean the columns, and I tend to put everything into snake case. By the way, if those of you that don't use R, don't worry about this too much. I'm not going to focus on that. So if Julia or SQL or Python is your poison, absolutely, a lot of this stuff should be very doable in those languages. So I use R because this is what I use in my day-to-day work. So that's the one I know best. But if you know, I'm trying to make these things as relatively simple as possible, certainly for this part of it. When it comes to some of the analysis later on, we will be using R packages that may not exist in your language of choice. I'm sorry about that. I mean, I guess it's worth looking them up, but yeah, that's the thing. So we can see here, create Excel date time. So you just multiply it by, I think it must be seconds from that time. So you multiply 60 seconds, 60 minutes, and 24 hours, and that gives you a date time from this particular date. And then we have this. I've changed the invoice date to invoice DTTM as in date time. And the reason for that is later on, I'm going to be creating an invoice date that's just a date. So rather than have a bit of mixed messages, and I know it's a bit confusing because I'm technically renaming it, but it was just easier to have an invoice date being actually a date as opposed to a date time. So that's kind of how I went with this. And then we're creating some derived variables. So missing customer ID, it's handy to have that as a logical, which is just that is customer ID blank, NA being a blank character in R. And a cancelled transaction is, so there are a number of transactions in here which are essentially returns. Now, the data on returns isn't great, and I will get to this later, but I thought it was just handy to at least have it as a logical. So we're just detecting it. So if the invoice ID starts with a C, so that's just a little bit of regular expressioning there. So if it's a capital C, and I think I checked as well, I think they're all in character, or maybe I changed it so that they're all in upper characters. It's a cancelled transaction. So that's, we'll process that slightly differently. And then finally, the invoice date is now the as date of invoice date time. So it's the data element of the invoice date time. So now we have a couple of new columns in there like we had before. And now if we look down, we can see that they're kind of in the format that we would want them to be, including some logicals. And now we're going to we've got all of that. Now we're going to check some missing values. So we can see about 25% of the customer IDs are missing. So I'm not quite sure why this is. This is something that you would immediately want to check. Like, is that right? There was some reference on the website, if you read about the data, that the customer, there is a wholesalers. So it's possible wholesalers just have a missing customer ID. I don't really know about that. And unfortunately, this is one of those things. And it's, it's not an insignificant amount of transactions. It's 25% of the whole set. So that's something we're going to have to think about, how we're going to deal with that. And it may be a question of just throwing it away. Depends on how big that is too. So that's probably something we're going to have to check. Like, how much of the total transactions, first of all, are they all positive and negative quantity? The other thing to look at is in terms of like the dollar amount, or the currency amount, which would be, the quantity times the price. How much of that has a customer ID versus doesn't? So how much of the data, if it's a very small amount, we can probably throw it away. Or are they very large items where it's a weird order? So there's a bunch of things to be asked there, and also how we deal with this data will also depend on what we're planning on doing with it. I mean, normally we will be coming on with some kind of agenda. Now I have these rough agendas of doing. There's a couple of different things we can do with this data. One is to do like attempt some form of simple like customer lifetime value style models, where we try and get some idea of who our valuable customers are. We could do some basket analysis using things called association rules, which show you kind of what items tend to get bought together. We could also do some like stock planning in terms of or invoice planning, where we can kind of see what kind of items tend to be bought at what time of the year, or just in general, like financial cash flows in terms of forecasting revenue. There's lots of different things we can even do with just this relatively simple data set. So that's one of the reasons. And also the other thing, sorry, I should have mentioned right at the start, is that I don't have a lot of experience with retail data. And one of the things I do with these workshops is I try and learn something new for myself. And, basically it's kind of a learn along thing with me effectively being one page ahead of the rest of you. So that was kind of the other motivation. So I am not an expert on this. And if any of you are, please shout out and let me know. I will more than happy be corrected. Or if there's like things, if there's some glaring things about retail and I say something stupid, which is entirely possible, please shout out and correct me, or just put something into the chat. I'm happy to be corrected. That's, we're all here to learn. Okay, so we've got like 25% of the customer ID. So that's definitely something we need to think about in terms of whether or not we throw that data away, because, how does this work? There's some stuff here in terms of, this is just the same plot. I have it in twice because sometimes you'll get data where essentially all the columns are missing because it's like a dump from a database and it's a bunch of fields that were added into the database schema but are never populated by the system. So therefore they always end up blank. So that actually happens more often than not. You'd be surprised. So I just have a bit of routine in that detects those and just gets rid of them and recreates the plot. So that's all there is. And you can see there, nothing else is really missing. I mean, it's hard to tell exactly because there could be a very small amount, although it looks like there isn't. There's just a small amount of the description that's missing as well. The one I'm looking at here is multivariate missing data. So, I changed this. So, crap, you know what? Hold on, let me fix this. So, multivariate. So what I'm trying to do here, and this is an important one, so I don't want to get rid of it. Where was the fill? It was down here, and I can go fill equals blue. And let me redo that. So what I'm trying to do here is, we were looking at missingness on an individual column basis. So one particular variable being missing or not being missing. But another thing that can be quite important from a data integrity and like data quality point of view is the co-occurrence of missingness. So, and I'm sure maybe there's work being done on this, but I don't know what else to call it. But it's the idea that some columns should be missing together. So, for example, if you have a set of data and it's probably a bit unrealistic in this particular example because, you know, there's only 8 columns, but in a lot of data sets you'll be working with, you'll have 30, 50, a couple of hundred, maybe even a few thousand columns. Most of them will be nonsense, but you'll have maybe a set of important 10, 20, 30 columns. And what might happen is that 2 columns should never be missing at the same time, or they should always be missing at the same time. So for example, in life insurance, or actually in a lot of different things, you'll have product codes, and you might have information on different products within your business, like in the one kind of data report. And depending on what the products are, you know, it'll have some type of value. And if it's a different product, it'll have a different set of columns of values. And what you want to make sure is that, you know, should these 2 columns both be missing at the same time? Because, you know, if it's let's say you're selling, you know, I don't know, I'll go with life insurance because the one off the top of the head could be a protection policy, which is your standard, what people think of as life insurance. You know, you pay a certain amount of premium each month or year, and if you die over in the period of time, you get a payout. Or it could be like a retirement product where it's not based on, you know, mortality. It's just literally you're making a contribution every month and they're investing the money on your behalf. So those different products will have different columns, you know, depending on what they are. Like maybe it's the name of the fund you're invested in, if it's a retirement product or a pension product, or it'll have like whether or not you're a smoker, if it's a protection policy. So if one is blank, then the other shouldn't be blank, and vice versa. So we need to kind of check that, because if that isn't the case, and this is what kind of this is plotting, and hopefully this crap. All right, let's go back to the original. I was hoping to be a bit clever about this, but this is what you get for doing things live. Fill equals missing prop, I think it's called. So what I'm trying to do here is just show in a visual format how, like, what's missing at the same time. And unfortunately, because of the proportion, some things are blank and some things are not blank. So what I would like to show here, and it will kind of ping through, is, you know, very visually, rather than try and manually do things, you know, a picture's worth 1,000 words. I want to be able to look at my code straight away and see the proportion of fields and whether or not they're missing at the same time, and then just get a sense of that. And that way I can look at it going, hang on, you know, those 3 things are all missing and they shouldn't be. Does that mean there's a problem with the dump of my data? Like, have I found something problematic in the data report I've got? Because if the, you know, garbage in, garbage out, if the data you're handed at the very start is not correct, well, then you're not going to be able to find anything. You can't be, you know, it's a difficult enough job getting something substantial at the best of times. If the data got is nonsense, it's impossible, you know. But having said that, that might be something they don't know. So the people who are handing you this data may not know this. Or, you know, rather than coming down a month later and finding it out after the fact, you know, you can do it straight away. Let's see if this works. I love that these things there. So yeah, this is what I'm trying to say. There's like these 2 here, customer ID and description. It's very, very faint along here because the missing proportion is much lower. What I was trying to do is basically have this highlight and have this all the same color. So I'll just need to get fix the code for it, where the color isn't a function of the actual color of the code isn't a function of that. It's an on-off type thing, but that's fine. It's, you know, I can just do it as an on-off and set the color with a true or false. But so you can see here, unfortunately, it's probably doesn't really come up on the screen, but if you render this yourself at home, you'll see that basically customer ID and description are ever so slightly colored tinged blue. It's very, very weak because the proportion is so low. But we should look at that and say, okay, well, that means that customer ID just occurs by itself. It's missing, and it's missing almost 25% of the time. We saw that in the last one. But now we know that, in a small number of cases, not very many, that's basically 0.5%. But it's still, it's 0.5% of a million. So, a million is 1% of a million is 10 grand. So there's 5,000 rows where both customer ID and description are missing. So, but also it'd be interesting to see if the description was missing, but the customer ID wasn't, or if the stock code wasn't. So these are all questions we kind of need to ask of the data. Oh, and by the way, I didn't copy this code for this data set. This is like a template I created ages ago. There is another very good one online, which is also in this container, called Data Explorer, which does most of what this does. I didn't really knew this existed when I wrote this. So I'm starting to kind of use a combination of both. But, so we know the customer ID is missing. We also know description. But when description is missing, customer ID is missing. So that's kind of interesting too. But it not in any other place, because it's 0 for the rest of it. So that's just a bit odd. Then we're going down the high categorical count. So we're kind of going down through the categorical variables. So we can see that, there's almost 55,000 invoice IDs. So there's about 50,000 invoices in the data set. Good to know. There's about 6,000 distinct customer IDs. So, and about 6,000 distinct descriptions, and more descriptions than there is stock codes, which suggests that the description and the stock code aren't necessarily a one-to-one relationship. And actually, I'm not sure if I have it here, but I had a quick look at this. I think I might have done it a little bit later on. Because description was a bit of a free text field, it does look like essentially it's the same thing, but it's written the other way around, like, red polka dot pillowcase, and then it has pillowcase red polka dot with the same stock code. So one of the things I also wanted to check for was, is the same stock code being used for more than one type of item in the data set? That's the other thing you would need to check for. And if so, figure out something to deal with it. If they're like, are they recycling stock codes around based on time? And if they were, then we'd probably need to come up with something, some kind of, jury rig based on time or something, where everything before this date and we combine the two into a new stock code, that kind of thing. So, but luckily it doesn't look like we have to do that. And then finally, there's 43 different countries in the data set. So, we have how many rows? There's just over 1 million rows. That's all good. And, we can automatically unique variables. There's no actually completely unique variables. So that's okay. And then we may exclude categoricals with high level counts, because we're not going to do that. So you can see that invoice ID, customer ID, description, and stock code are being excluded from whatever, the simple stuff that we're going to do later on. And then finally, we kind of write it out. I've actually suppressed writing out to disk. We'll probably look at it later on. Okay. Anyone got any questions before I move on? We're going to quickly move down through this. So we have some, I'm keeping an eye on chat if anyone has any questions. So we're going to look at the various things. I've split them out into their types. So we have discrete, we have date time, we have continuous, and we have logical. Now, logical and discrete are kind of the same, but it's handy to create different plots for them. And also date time is technically a numeric, so we could lump it in with continuous, but it's just handy for formatting and stuff to treat it slightly differently. It also means we might want to do slightly different plots depending on whether it's a date time or a continuous. So while at the very high level, yes, it's the same thing, their interpretation are slightly differently. So I treat them different. So we have some logical variables. So essentially we loop through all of them. So we see missing customer ID. That was that derived variable, that whether or not the customer ID is missing. We can see that, ties in with what we knew about 22% of the rows had missing data. That matches that. Cancel transactions. The vast majority of data is not cancelled, but there is a few, and it's not none. So we're going to have to look at that. I think off the top of my head, there's about 23,000 cancelled transactions. We're going to have to figure out how we deal with that, because that could be important in terms of both customer lifetime value, demand forecasting, and getting a real, idea of what's going on. Because we might find that of the return data, like a lot of our sales ended up being returned. So if we ignore the returns completely, then we might have a problem. However, while I would absolutely include them normally, there is also a problem with this data set in that return data doesn't have an invoice that it's linked to. So, you know, if you were returning data, we're going to have to figure out some way of matching that return to the purchase and try and figure out how that works. And there's a couple of things we can try. I'm not particularly happy with any of the things I've came up with, to be honest. So that might need a bit more work between now and the next workshop. Going on to numeric variables, we have a quantity. So I have the, I've done a bit, I can, hold on, I can fix this. So we're just looking at the histograms of it, but what I have done, and I should have it in my other code, the last time we looked at stuff, it was a little bit, like I wasn't particularly happy with the work we'd done. So like some of the values are negative, for example, so we do have some negative values in there, and also it's with a numeric, especially when it's skewed, it's sometimes useful to have a log plot. So I had this where I combine the two together. So what I'm going to do here is I'm going to paste in some code, and I'll quickly talk through it without, you know, going heavily into the R code of it. But basically what we're going to do is we're going to break the plot up into essentially a 2x2 plot with one panel missing. So what we're doing here is we have, this is all ggplot, so don't worry if you don't know, but we're splitting the data up into negative values and positive values. So if the number coming in is negative, we're going to essentially plot all of the data, but we're also going to have a plot for the positive data and a plot for the negative data. For the negative data, we're just going to negate it and then calculate it on a log plot so that we can kind of do two log plots together. So let's just run that code and see how that works. So the idea here is rather than just have the overall data together, sometimes when you have negative values, it can be handy to just, you know, look at the negative values as well as the positive values and do it on a log plot, because sometimes, especially continuous data, can often be quite heavily skewed. So a histogram, which is usually very, very useful if the data isn't massively skewed, it kind of becomes crap, because what happens is you get a whole load of data down, well, from your point of view, this side of things, and then, you know, this big long tail of values, and it just doesn't tell you, a lot. And we've got some issues. What's the problem here? Attempt to use zero length variable name. I will have to fix that later. So let's just move on and I'll fix that in the break. But yeah, so especially for things like price, and I added a few extra values in, and that would be useful. And now we're looking at the categoricals. So we have the country here. We can see, you know, the vast majority of the data is the United Kingdom. And then we have, you know, a small bit ERA. You can tell it's a UK company because they say ERA instead of Ireland. That's one of the weird things I found about working in the UK. They said ERA a lot, which, you know, no one ever really uses here. And then we've got our plots of our invoice dates. All right, so none of them really, you know, stands out there. The one thing I would like to look at is the price. So the price does have some negative values down here. I presume that's because of the transactions. It's relatively skewed. It's relatively, you know, symmetric around, you know, whatever that mean price is, which is about £5. So it looks like most things are about €5. So the green line is the median, and the median value is 210, and then the mean price is 465. But there is this big long tail of highly priced items, which goes all the way up to 100,000. You see up there. There is a very small number of transactions for very large amounts. I think in like the 20, 30, 40,000 pounds, which was a bit strange. And again, not exactly sure what we're going to do about that. We're probably going to have to think about, you know, do we treat them separately? Like, do we look at the extremely high priced values? How do we treat them? Like, do they get returned a lot, or do they come through? Because again, from a retail point of view, like, most of your profit might come from a very small number of your customers that are extremely profitable, and the rest of your customer base essentially just pays for the ongoing of the business. But, you know, it's the whole casino whale thing. For those of you who are familiar with like Vegas or Atlantic City or any of the casinos, typically they make their money off the really high flyers, and they're the average everyday show who comes in, so retirees usually that come in and just feed money into the slots. What they tend to do is just kind of pay for the upkeep and pay for the the maintenance and cover the wage, various costs that have to be paid, and then the money is made off the whales. So you might not want to ignore the really high price values either. I mean, I don't really know this. I'm kind of speculating here because, and this is what I'm trying to capture, is that like a lot of this is unknown and a lot of it is quite speculative, and we just don't really know until we dig in and deep it. But it's important to start asking these questions now so that we have some idea of what to do and where we're going to go down the line. By the way, if any of you have any questions, I'm very conscious that I'm talking a mile a minute. Oh, there's Neil waiting by price. Okay, cool. I might get you to talk about that a little bit later, Neil. I had weighted histograms waiting by. Oh, okay, sure. Yeah, so one of the things we're going to do next, as soon as I finish this, is we're going to start adding in some extra derived variables. So basically, we're going to scroll back up to the top. And again, and I haven't copied and pasted in yet because I want to show kind of the iterative nature of this. So we have some code here, we have some plots, but we don't actually have very many. There's what, like 12 or 13. I mean, we got rid of a bunch of them. But what I would like to do is start, there's quite a bit of information, for example, around the timestamp. We have, the year, not so much because there's only 3 years in it, 09, 10, and 11. But like the month of the year, especially for retail, is probably quite important because of Christmas. What time of day, what day of the week. There's a whole bunch of calendar effects that we can probably look at that are worth investigating. So if we add them in as derived variables at the top, this process will just spit them all out, and we can do all this analysis of them after that. And what I'll do is, yeah, I've got that prepared, so I'll at least see if this works. And if not, I've just noticed it's about 7:45, so now is a good time to take a break. If this all breaks immediately, we can take a break here. But what I'm going to try and do is break in a bunch of derived variables. So let's just copy and paste this to talk about it. So hold on. So that is, what is that going to create derived variables? So let's go back up to our code. So we had all that there, glimpse. So we're going to paste in a bunch of new values. All right, so what are we looking at here? So I've renamed invoice to invoice ID because it was just known as invoice before. And again, invoice is okay, but invoice ID is a bit, in my head, is a better name. I've added a row ID so that every single row has a unique ID. I figured that might be handy for later for linking things up, especially if we want to link transactions, returns back to their purchase. So it's just handy to have a unique ID. I can put in that before. This is a bit of dplyr code. It basically means add it to the front, to the very front of the table, whereas by default mutate adds on to the end. And then we've done a few bits and pieces like stock code upper. I'm just translating everything to upper letters so that when I do this invoice, that capital C will match. Invoice DTTM is invoice date, and then the date is the one before. And now we're adding a bunch of things like what was the month, percentage B, the day of the week, capital percentage. And these are all standard, what are called STRF time, which is from the C library. It's pretty much universal across every programming language because I think there's a C library for it. So it's kind of the standard formatting for dates and stuff. So it's just a handy way, and it turns everything into categorical variable that we can then process. And then I'm adding another one like stock amount is price times quantity. So that's handy to know, like how much was actually spent on that particular line item. Like I said, because it's a transaction data set, technically a transaction is probably an invoice, but in reality we're doing line by line. So one invoice might have multiple rows in it if there was multiple thoughts. So it's kind of a basket line item is a row of data. So we're also going to be grouping by invoice year month. And then what I'm adding here is just the month proportion. So what I wanted to do here was the calendars are a pain in the arse, and notoriously, because sometimes it's 28 days, sometimes it's 30, sometimes it's 31. What I was trying to get is I didn't want to use the day of the month as a measure of progression through the month, but what I figured here, this could be a useful variable for just figuring out how far through the month are we, and is there some kind of signal in that? Now, I have absolutely no idea if that's true or not, but I figure it, what the hell, it's worth a shot. So what we're going to do now is we're just going to reknit that. This is probably going to fall over, and if we are, I'll fix it during the break. But yeah, and then now, yes, here we go. Oh, so I need to fix all this, so I can do all this in the gap. There's probably some stuff I just need to copy and paste across from this other code. So what we're going to do is we're going to redo this, and that's a good place to actually take a break because I just see it's 10 to 8 now. So what we'll do is we'll take a break here while I'll fix this code. We'll come back in about 10 minutes and we'll go through all this, and then we'll start going on to slightly more interesting stuff like doing some aggregations, doing some plots, looking at a few different things that might be of more interest, that are more specific rather than just looking at individual values. We can do some explorations based on the aggregations we do. Okay, anyone got any questions? But if not, what I'm going to do is I am going to pause. I'm not going to pause the recording, but what I will do is I will stop the video here, but I'll keep the screen sharing up. But if anyone has any questions, feel free to just stick them in the chat and I'll address them after the break. And I'm just going to go on mute. Okay, talk to you soon.
I think you've gone mute.
I have, yeah. I just put myself on mute because there's a bit of background noise here. That's all. I'm still here coding away. And we're just on a break for about 5 minutes. Okay, I'm back off mute for the next few minutes either. If anyone has any questions for me while I try and fix this, by all means, give me a shout. Failing that, I'll just keep plowing on. Just get that out. Invoice. Just make sure this works on this other piece of code. See, does that come out? No. Invalid trim. Must be the way the format is done. So okay, so that worked. So I wonder, is it just the order which I'm doing that maybe? On the day week, we need the date stamp. You know what? Let's just move it up here. See what. All right, so let's come back. And unfortunately, we've hit a snag, but that's fine. So this is why we use source control. So what I can do is I can go into my source control and hold on, things are being a bit slow here. It's like my screen has. Can you guys still hear me? Yeah, you can. And can you see my screen?
Yeah.
Looks like something's kind of frozen. Just give me 1 sec and I'll bring it back. Yeah, it looks like, sorry, I have a machine running here and it looks like my machine has, let me just stop this. Apologies for this, folks. I'll be back with you shortly. Yeah, it looks like I've got a local Docker machine running on this machine, and I forgot why I didn't do this the last time, and that's to avoid this situation where I end up eating up all my memory by just doing something weird on the background. So just give me 1 sec. I just need to kill that process, and we should be okay. So I will just kill Docker. And that should free up a bunch of memory, and we should be okay to go again. So just give me 1 sec. Okay. Yep. Okay, while I'm waiting, does anyone have any questions? Neil, you were saying something about, in the previous one, actually, you were saying you messed around with weighted histograms.
Yes.
What were you doing there?
What
I may as well have something to talk about while I just recover the memory on this machine.
was I doing? I think it was an insurance data set or something. I remember, but so I had claims, and so you could do a histogram of claims,
Okay.
and then you can just weight the histogram by the size of the claim as well, and that will show you the money value for each range of claims. And I just thought it was the easier one to go, because I wasn't sure whether like the high claims were really important or not. But when you did the histogram with the money value, then you said no, they weren't actually, because if they were, you'd see a big lump to the right, if you know what I mean, on the histogram.
Yeah.
I don't think it's in the default in our. I can't remember. I think it's in the library, but I can't remember which one. But it's easy enough to find. Yeah, and I was quite pleased with myself going, oh, that's something I'll have to remember next time I'm looking at those things. That was mainly what I was thinking about. Is it completely dominated by the extremely high claims?
Yeah, like
to check and went, oh,
like
no.
an empirical cumulative frequency type thing. Is that what you mean?
No, it's just normal histogram, but weighted by the money value, so that you could then see which ranges were the ones with the biggest.
Yeah.
Were actually the most important in terms of money value, as distinct from the ones that were just most frequent, which is what the histogram normally shows you.
Right, so let me just git check out explore retail data. Let's just wind this back, because that seems to have messed up a little bit. Yes. So we can go back here. Let me just copy and paste this data. I would love to say that this is just a snafu, but this is how messy it gets in real life, folks. You know, sometimes you just kill your machine when you're by, you know, not really doing very much at all, and suddenly your machine is dead. It does happen. And it happens me a bit because I do tend to be working with a bit larger data sets or with large kind of examples of, you know, when I'm running Monte Carlo simulations and stuff, and it just kills all your data. I have no idea why that was. There's no way that should have happened. But, you know, I do find sometimes running Docker on my local Windows machine does sometimes kill my machine. So, all right, we're going to rerun it again. Hopefully it'll run this time. And we're going to walk back. Yeah.
I have a suggestion for me.
Yes, of course. Shoot.
So some more programmers, you sprinkle, you know, GC brackets reset equals true, you know, some garbage collection through your program.
Yep.
Just
I've tried that. That doesn't that still kills it. I'm very, very good at eating up all the memory on my machine. I've tried that from time to time. Sometimes you just GC never really works that well for me. Sometimes I just have to kill it. I do have it a bit further down when I'm deleting some larger machines, but no, I think this was something else. I have had some issues with running Docker in WSL2 on my Windows machine, and I think that's what happened. I just ran something and it just killed the machine. What I should have done was run everything in the cloud as opposed to the machine that I was recording on, which I remembered to do the last time. But yes, thank you for that suggestion.
Or a Linux partition on your Windows laptop.
Yeah, I used to do that, but I switch back and forth all the time, so it doesn't. That would be kind of something I used to do, but that just got far too messy. It's just easier to have WSL that you can do the simple stuff on and then go into the cloud when you've got your chunky stuff to do. Okay, so, right, where are we? Let me just refresh this page. So I've had to roll that back. So we're back to the original version. So what I was trying to do is put this data in. For some reason, it works on this other machine, but it doesn't work on this one, and I'm not quite sure why. So what I will do after this workshop is just copy the code over. You can see it in my other repo. I have one that has all this data in it. I think there's just some issue with date times. It's probably like one piece of code that I've just forgotten to include, which is always annoying and always happens when you do this kind of stuff. So, okay, so where were we? We were in the univariate. So we have some categoricals, we have some date time. So now what I added on is a little bit of facet. So this is all part of kind of the other thing, just getting a sense of where the data is going. So what I'm going to look at here is just some facet plots. So we kind of have the same data that we had before, but now rather than we pick a logical variable, and in this case we kind of can do it randomly. In this case I've gone with missing customer ID, and we just do a plot to see is there any, and you can do this for as many as you want, but I generally pick one that seems to be more important. What we're looking at here is there a big difference between transactions that were cancelled versus transactions that weren't cancelled? And then you just create the various bar plots or histograms and you put them side by side and you check what they look at and see are they particularly different. And then we can start adding in, you know, so you can see we have positive and negative prices here. So, you know, the prices are only positive for non-cancelled, and there is one positive price for a cancelled one. So that's something we need to look at for a price. Like, so you would expect the price to be negative, but maybe not. Maybe the price and the quantity is negative. It's hard to say. So, you know, there's some weird stuff going on here with both missing price for missing customers. So this is something we need to look at. And what we're trying to get here is just, again, we're not trying to build any models yet. We're just trying to figure out what the data is and what, like, the suggestion might be to end up throwing data away. You know, we kind of, you know, it might be, so there's a lot more companies for countries that for purchases with missing customer ID, with the country. So there's no customer ID, but there is a country, which is a bit strange because maybe the country is where it was delivered to. And again, this is something we would know if we had access to the data. So what we're probably going to have to do is guess. So we probably know where we sent the item to, but for whatever reason, there's no customer ID for it. Probably, maybe this ties back to the whole wholesaling. So maybe if there's no customer ID, it's because it's a wholesale gig. But even though we know where we sent the stuff to, so we have a country for it. And for returns data, there's much less. So we can see there's Bahrain, Bermuda, ERA, chunk in ERA, and then most of them are in the United Kingdom. So we have Ireland there, and this kind of maps what we had before, because you can see here, like Ireland is this chunky jump here. Interestingly, they've European community. Huh. Wonder what that. Okay, European community as opposed to, you know, the individual countries, which we also have a list of. So that's some curious stuff. It's probably was a free text thing, so that's the way it's gone in. And similarly for customer faceted. So if it's missing, we're not seeing a huge difference across the invoice dates. Okay, so that's kind of where we got to now. Unfortunately, my code isn't working here. So what I'm going to do is I am going to switch to the github.io. So it's DDS soup to nuts. Nope, what is it? Hold on. That is, sorry, that's one. It's data workshops. And then it's this. So this is the kind of what I'm working on in the background, and we'll just go with that for now. Exploring retail data.html, and that should be in there. Yeah, so here's kind of one I've done earlier, so you can see there's a lot more in there, and that code should work. And okay, let it just render up. So this data got put in there now. So we have some, you know, the data we added in. We're looking at the data, we're checking the dates. So we want to check it for missing dates. I've added this data table, which is a JavaScript library, which you can add. It's kind of part of the Shiny routine, and it just is handier for looking at dates. So we're checking the date and the invoice date and the lag invoice date. So we're looking for missing dates. So when you do the plots later on, you'll see that there's gaps. And so I wanted to check, like, oh, 2 dates. So if it isn't immediately missing, you know, what's the date difference between the previous date? So you can see there's 2 dates, and it's generally on a Sunday and a Monday. Now the Sundays are because, you know, the shop wasn't open the week, presumably, so that's why it's 2. But there's also these 2 larger gaps, and the great thing about data table is we can search. So there was 12 days, and that's around Christmas. So you can see there it was the 4th of Jan. It was the 4th of January and the 4th of on both years, and it was 12 days. So obviously, what happens here is they take about 2 weeks off around Christmas, or 10 days, or whatever, which is fine. What it does mean, though, is if we're doing some time series stuff, we need to be a little bit careful because there's going to be big jumps in the data, and most time series don't assume that. They assume that the gaps. So if we're doing some kind of time series data in there, we're going to need to account for that. So we're going to have to look for that. So that's kind of just something to be aware of. We can check for the missing values. Like I've added a bunch of code in there, and this will show the plot here. So you can see what we've done is the month proportion here. We have the main plot here, where we have kind of the, you know, the mean and the median. But then I've taken the positive values and the negative values, and I've done a log plot, like a log scale on the x-axis, and that gives us a better sense of the value. So you can see here, like price is pretty much on 0 because most of the prices are very small. But then when we do a log plot of the positive values, we kind of get much more of a bell curve with this long tail. And then we have a bunch of negative values, you know, minus 10,000, minus 30 grand, 40 grand, and 50 grand when we look out here. So yeah, we do have some very large negative values on price. So another thing we're probably going to have to check is, are price and quantity negative at the same time? Similarly for quantity, we also have the stock amount, which is like the price, the quantity times the price, and you know, we have negative values there as well. But one thing I want to check on that now is, you know, stock amount should be always positive. So what I might change that this is kind of an iterative process. When I go back up now and I'm looking at this again, what I might do is take the stock amount and always make sure it's a positive value rather than worrying about negative values for returns. Just look at, you know, the cash amount in the transaction, whether it's a positive transaction or a return amount. And then, you know, deal with the fact that it's a return in a separate variable. But that way you're not mixing with negative variables. The country happens again, and there's the Excel sheet because we had it in 2 sheets. The day of the month. So we can see there was no trading ever done on a Saturday. The invoices are never done on a Saturday. Which is curious why Sunday's open, but Saturday isn't. That's, I guess, it's just whatever way they've done it. The invoice hour of the day. So you can see we have, you know, basically they only trade at night, which is because it's an online store. So maybe they just don't take orders, or they only create orders manually rather than being done automatically. I guess things like Shopify and all that weren't around then. So maybe they just take their orders in off the website, but they had some kind of manual process for creating the invoices or something like that. I do find it curious that you only have invoices between, you know, 6 in the morning and 8 at night. For an online business, I would have thought it would be 24 hours, but the fact that nothing on a Saturday and only during work hours is curious. So there obviously is quite a strong manual element, which would also explain, you know, the fact that the data doesn't quite match up in terms of returns and stuff. So I thought that was quite interesting too. And we have the minute as well. So, you know, pretty uniform, nothing particularly interesting. And then we have other. So yeah, they must be all the other ones together. So yeah, so what I do there is I look at the top values and then everything else gets lumped into other because it's categorical. And what's happened there is I have too much. I should actually suppress it for this one and allow 60 categorical levels. Whereas in this case, I think I only allowed 30, which is why this other is so big. But to me, it looks like going off the random sample as well. There's a bunch of dates, like minutes missing. Looking across there, there's nothing particular about the minute of the day. But I guess if it's a manual process, there wouldn't be. The invoice month, I need to fix this because this has been done. I need to change this into a factor because it's sorting it in order, but the order is alphabetical rather than the calendar month. So what I could do is change this into a factor where, you know, 1 is January and 12 is December. And that way I would get the calendars there. That can look on. Oh, hold on, we have a thing. Nothing on, yeah. That is entirely possible, Patrick, and that's why we do this. Sure, I don't know is the short answer. I can certainly check. It might be there might be out by 1, I guess, on account of how I've converted in Excel. But as far as I'm aware, I've converted from Excel properly. But that's worth. I think I did it right though. I think when I checked that because in the Excel spreadsheet it was registering it as a timestamp. So when I compared what was in what I was reading in the spreadsheet, well, you know what? That's a good thing to check. So this is why we do this. So let's take a check and see, because exactly, you're right. It's very curious that there's nothing on a Saturday and not on a Sunday. So these are the kind of things that we should look at. So that's a good point. So what we're going to do is let's get the data up and let's just data. And so we have here, the time is 2009. So let me just get the stock code. So let's pick a date. Invoice DTDM is greater than or equal to as date. So let's pick 2010, April the 3rd. Time zones are inconsistent, so maybe that's a problem. Maybe there's an issue with the time zones, but I don't think so. I'm pretty sure we put it all in there. So now what I'm going to do is let me just share my full screen. New share. Let me just share my full screen so that you can see what I'm doing. Okay, so if I go into the data. So let's export that. where is it? This out. So if I export, that way I can download it to my disk. Just open it with LibreOffice. Someone's unmuted. Do they have a Neil? Do you have a question?
No.
Oh,
I
sorry.
forgot to.
Okay, sorry. It's okay. All right, so let's have a check, because that again, this is kind of important. If we're going to work off the timestamps, which we are, it's important to make sure that we've got the dates right, because this is how we do it. So what we've done is I've taken the data here. So we're going to say on the, we have this invoice ID 503596 and this stock code, and we have this date here, and let's check to make sure that those dates match whatever we see in the, oh, it's just been slow now to load. Shouldn't be that slow. I'm wondering, is my computer just kind of borked? Oh, here we go. Borked from earlier. Riveting viewing. I know. So okay, so we have, what date did we put in? We put in so it's 2010. So let's just check. That is, let's just check the top here. So that was the 1st of the 12th. So it'll be this one here, and it'll be down near the bottom. So let's scroll back up a bit. What did we say the date was? We said the date was, hold on, let me just copy and paste that. I'm just going to put this into the chat. Let's see if this matches up. So it was 2010, and it was the 6th of April. So 6th of April, here we go. Move down past it slightly. So 6th of April, here we go. And it was 0920. Let's click up. This is where I'm really showing off my Google skills here. My Excel skills. Because I know I could probably use autofilter, but I've always messed that up. So, okay, 09. So, so 50, so what? 503596. 503596. 0921, yeah. So it's 84467. 84467. Yeah. I mean, at 2159, and then it's 928, 503597, 503597, and it's, so those dates are there. So it is curious though, why, what's that top column? That's the customer ID. So yeah, I mean, seems to be, they seem to match. It is curious though. I wonder maybe if they got their dates messed up, but that is weird that it will be closed on a Saturday and open on a Sunday. Unless they open on a Sunday because they want to take orders and like send out stuff, but it's like a homeware thing. You would imagine Sunday would be the day it was closed. But yeah, that's curious. Anyway, that's definitely something I would be checking for when we're, you know, looking at stuff later on. All right, so what else are we going to look at? So there's the facet plots. So categoricals, there's the county, there's the hour, the minute, the month. Yeah, maybe the time zone. Yeah, let me look at that. That's definitely curious because, but then again, the days of the hours. So I have fallen into this before, and this again, I'm a bit sensitive. I appreciate that, like taking like 10 minutes out to check this seemingly minor issue seems probably a bit extreme, but in my experience, you know, oh, hang on, did I start my video? I never did. Let me start it up again. In my experience, you know, messing around with time zones is an absolute nightmare, but also really important. So because my background was in finance, we had to work on the different like time zone differences. Like a lot of times were set in the East Coast versus the like GMT. And generally what I've decided to do whenever I deal with time zones now, I just work in like UTC/GMT, just work in universal coordinate time. If you're presenting times to the user, by all means change the time zone for presentation purposes. But whenever you're convert everything into UTC and stick in UTC for everything, because otherwise it's a complete nightmare. And that might be something like that about that. It does. I completely agree with you, Patrick. It seems a bit weird. And it's coming off Excel as well, which also isn't great on the old data integrity. Now, I know you'd know more than I do about that kind of stuff, but yeah, it's a bit weird. And also, like looking at the months, you can see, you know, they have a big spike in November here. So, I mean, yeah, we'll have to check that. There does seem to be like an out by one error, but again, this is what we look at. The invoice, the week of the year. So, like how far in the year we go, it's moving up. And we have this big other. So again, the automatic clustering of categoricals is kind of going against us for this. So I might suppress that or maybe make it 50 or 60 or something like that for these ones. Maybe not traditionally Irish Sundays. Yeah, really, yeah, true. Possibly, it could be the Sabbath. That yeah, if it and it didn't say, and it wouldn't say. So if it was some kind of, or Islamic or Jewish business, they might not work on a Saturday and just work on a Sunday. That's a good point. That could be what that is. Which is an interesting show of differential privacy. You're actually revealing quite a lot from data that you wouldn't think is in any way connected directly. And this is why differential privacy can be so difficult, because you have to really know, like, you can't just say, oh, it's okay, we've anonymized this data because, we've changed a bunch of stuff. It's amazing how much information can leak by combining a bunch of different kind of things together. But anyway, I digress. All right, so the invoice and the year months. So what I did here was I just took the year and the month and combined it into a categorical and then plotted across. So again, you can see we have a big spike in November here, not so much in December, and another big spike in November here. So, we can see kind of things ramping up into the Christmas period, and then they're lax in January. There's a slump in January, February, which we also see here. January, February, there's the drop off there. Although much bigger drop in December here, actually, which is, and there too, actually. Oh, but it's not a full, this one here doesn't really count because it's not a full December year. Then again, neither. Whereas this one was, because this one finished like on the 9th of December. So we wouldn't necessarily see all that. So that, we can't really count for that. It's not fully adjusted for the full year. Which reminds me, we should probably, the month proportion also needs to be fixed then for that month, because what I was doing was dividing it by the largest thing in the year rather than in that month, rather than the largest of the month. So I should so in that month, the month proportion will go from 1 to 9 days, and 9 days will look like it's 100 through. So that's another thing I've polluted my data with. So I need to fix that. Okay. Invoice date. Yeah, again, we can see there's, some drops during the year. That's all fine. Invoice date time, and then back onto the bivariate data. So in this one here, I split by Excel sheet because I was conscious that the data was split in two, and I wanted to see was there any big differences between them. Whereas before I looked at cancellation, and essentially all we're scrolling down for is to just see, do any patterns stand out? So just looking at them, nothing. I mean, these are all kind of useless. They don't really tell you much. But these box plots might. Not much there. Nothing really stands out as being different here. I guess day of the month, maybe a bit of a drop off. But then again, that's the functions aren't. Yeah, the data isn't fully split because of the way they did it. So yeah, probably less interesting. Again, no Saturday. A small amount of Saturdays in this one, and none at all in this one. So that ties in with the plot of what we said before. Histogram of hours, they pretty much look the same. So we're not really seeing much of a difference. There's no real systematic difference between 1 month and the next, which I think is quite interesting, between like the first tab and the second tab. So across the 2 years, we would kind of expect them to be roughly similar. But anyway, we've had it. So the idea of all this is just to kind of ask all these questions. November have Thanksgiving. Yeah, I mean, so another thing we might do is get the dates of Easter, Thanksgiving, Christmas, and maybe 1 or 2 other holidays, and just put them in and flag them, maybe add an extra column of a holiday, or maybe a categorical to say when was the holidays. And that way we could plot them with a separate color or something in our line plots to see is there patterns around the holidays that might be useful. That would be something we would kind of look to do. Now we're going to look at data integrity checks. So we're going to basically look and see what's consistent. So we want to get a set of all distinct stock codes. And then this goes back to the point I'm saying, like, let's look and see what is matched. So you can see here that, like, stock code, and then if it's 2 values of the same thing. So we've got some errors here, but this is a mistake. I think what we really need to do here is filter out the returns have these extra things in them in the description, like zebra invoicing error. So there was a doggy rubber, and then there's things like that. So realistically, we need to go back and fix that and get rid of the returns and just look at the purchases rather than the return data, and check the invoices for that and see how that works. Let's just do that. We can do that quickly just to see. So if I'll go into this and we have our data to show that, and we go select stock code and description. So that gives us our 2, but before that, we're going to filter out where the quantity is greater than 0. So we're just looking at purchases. Okay, then what we look at is distinct. So we're just getting up all these distinct ones, and then we're going to arrange. So group by stock code, and mutate row count equals n. So what I'm doing there is I'm grouping by stock code, and then I'm going to ungroup, and then I'm going to filter n greater than 1. So what I'm doing here is filter is greater than that. Hold on. Oh, sorry, filter row count greater than 0. So what I've got here is a list of stocks where the stock code appears more than once and it has a separate description. So let me just do a descend on arrange desk row count. So we have 7 of them, jumbo bag. Oh, they should go. All right, so Amazon, no, they should be, quantity should be greater than 0 there. Okay, so that's, so instead, let's just arrange by stock code. And you'll see what I mean about earlier about inflatable political globe, and the description is blank. So we can get rid of them because that doesn't really tell us anything. So let's also get rid of quantity greater than 0 and where the description isn't blank. Let's see what that tells us. So yeah, so you can see like 105058, blue, white spots garden parasol, and then blue polka dot garden parasol. And then pink, white spots garden parasol and pink polka dot garden parasol. So you can see that a lot of these doublers aren't necessarily, you know, the description is basically two ways of saying the same thing. So we've probably got, it's kind of what sponge. Oh yeah, that's a misprint. So I'd say what happened there is there's some kind of like user entry data where people are just typing stuff in or copying, pasting or whatever, or the system changed over time. But most of these doublers that we can check, and we'll go through more, I'll go through more of them. And this is kind of the grunt work, just checking to make sure, but it looks like in general, with a few possible exceptions, most of the, and this found, I don't know what that is, that's probably something we'll have to look into, but we can just do a search on that. But yeah, what we would do then is we would dive into all of these and look at all these kind of weird things. But what it does mean is that we can probably focus on stop code mainly and make the, without being perfect, make the assumption that stop codes haven't been reassigned to multiple items so that a stop code is like unique within the data. And we've kind of shown that. And even if people insist that this is the case, this is the kind of thing you should always check. It's a bit like tests for code. You always assume there's problems and you try and look for them. And hopefully they all come back and they pass all the tests and nothing really worries anymore. But, you know, these are the kind of gotchas that can be very hard to spot and can have a significant impact on the work that you're going to do later on. So this is kind of why I know it sounds like I'm being like overly fussy and checking all this stuff, but, you know, garbage in, garbage out. And if you mess this kind of stuff up, it can really throw what you're about to do later. So we're okay on that front. So now we're going to look at some aggregate amounts. So just some simple things like, for example, I'm going to group by invoice ID. And then, oh, let me just maximize this, by the way. My apologies, I should make this much bigger. I did that earlier, but not with this one. All right, so we're just going to group by invoice, and then we're going to, the invoice amount was just the sum of the price times the quantity. So for every invoice that we have in there, we're just looking at exactly what they are. And then we're just calculating the mean and the median. We're rounding everything to 2 decimal places, and then we're creating a plot. So we can see in terms of the actual currency amounts of each invoice, you know, we have a reasonable plot. The average is about £350. The median is about £200. But there's this big long tail. I have it on the log plot here as well. But there is a big long tail going up to like 10 grand and more than 10 grand. So, you know, we do have, it's probably, we need to pay attention to these larger amounts, even though there's not very many of them. We certainly need to start looking at the bigger ones. You know, we just don't really kind of, we can't just throw them out and say, oh, they're just large values and, you know, we can just safely ignore them. We certainly can't do that without like a conscious effort to figure out how we're going to do this. And if we are we going to treat them separately? And if so, how? And if we are treating them separately, like what's the threshold? Is there a very obvious threshold in an invoice? Or do we just focus on the larger invoices? Because maybe that's what's worthwhile. You know, like I said, one of the things I really liked about this data set once I started looking at it was, it just occurred to me there's lots of different ways you can use this relatively simple data set to ask and in many cases answer, you know, some interesting questions. Now we're going to look at the customer spend. So same idea, but now we're doing a group by customer ID. Where we add up the price by quantity, we round to 2 decimal places because that gives us nice pencils. And then we're looking at the spend. So I didn't bother with an average here, but you can see we have a few real whales here. We have customers that have spent over like 100 grand with the company. And I presume this is all in pounds sterling. But, you know, so we do have some customers up here that are, you know, very highly valued customers, I would imagine. Now, the other thing we would probably then want to look at is maybe, you know, the distribution of spend versus number of transactions. So like, are these customers here, they've spent a lot, but is that because they're frequent customers, or are they the type of customer that just comes in once and then spends a lot of money? and you would treat them very differently. So how do we, how do we look at that? And I haven't got a visualization for that because, one of the things I want to do is actually talking it out loud. But it would be nice to have a visualization where we have like the total, we have some kind of heat map where every customer has the total amount spent and then like the total number of transactions maybe, or some kind of distribution per customer. Another thing we might look at is take like the 20 most spendy customers and do a distribution of their individual invoice spends and how do they work? Do they have returns? Because we've kind of ignored returns here. Oh no, we're not. We've included it, I think. Have we included it in there? Yeah, it's all the data. So we're grouping. So if there's returns in there, it should account for that. Unless both price and quantity are negative. So I do check that. That's something we'll probably need to fix on that front. Yeah. Do you follow what I'm saying there? Because if a return has both a negative price and a negative quantity, that multiplication is going to become positive and it's going to get added to the total spend. So that number is going to be inflated, especially if it's large value items. So big ticket items could skew this. So that's a problem with this visualization and we need to think about it. So that's interesting to know. The other thing I wanted to do then was create a hill plot. So yeah, exactly. Should take absolute price. Well, I'm going to take, thank you, SM. I want to take the absolute price and also check that the quantity is always negative. That's something I need to check as well within the data and plug that in. Actually, yeah, no, I don't have the code here because this is Bork code, but there's a bunch of stuff to fix on this. The other thing I like to look at, and this is something that came from my insurance days, is looking at extreme values. So basically, this is like a log plot. So there's a thing called a hill plot. So for those of you who aren't familiar with like extreme value distributions, it's like a Pareto. So the Pareto is like the 80-20 principle where 80% of the money comes from 20% of your staff. And it was like, Pareto originally came from wealth distribution. It was like 20% of the people had 80% of the money. And it's basically called scaling, like log scaling. So the idea is that the frequency and the magnitude on a log plot, if you take a cumulative like frequency and a cumulative value and you take the log of both, you get a straight line. And it basically means you've got the Pareto, which is like a big long tail, really, really long tail of extremely high values, which you would typically see in these kind of things. So what the hill plot does is it shows you how the high values exhibit kind of behavior. So what's happening here is like it's looking at the threshold and it's basically counting these values less than 90,000, less than 5,000, less than 3,000, or order statistics in terms of the numbers. And then it's calculating the scaling parameter of the Pareto distribution. So essentially what you want is this horizontal at the start. And if you get something that's vaguely horizontal, and it certainly looks like it is within, up to maybe a few thousand, you could certainly argue that a flat line is within the confidence interval there. It suggests that at the high level, we might have to start thinking about some form of Pareto scaling if we want to deal with those high numbers. Or it also suggests a threshold that we could cut things at to say if we don't really care about the really high value things, or we want to do some kind of subset analysis on the more everyday transactions, these kind of things suggest a good plot. So looking around, maybe total spend of being around 2,000 in terms of your customers, that's a good point, because after that you're into the Pareto principle. So that's kind of the hill plot is something I discovered. It took me a while to figure out because of all this, but basically this isn't two axes, it's just two ways of labeling the same thing. Down the bottom, it's just like the 15th highest value is about 90,500 and so on down. And these numbers down here, like this is the index and this is the value in the data set. It's handy for looking at that. So there does seem to be evidence supporting some kind of Pareto-based behavior at the high end. Now, certainly not after that, because it just tails away, and that means basically it's not Pareto at all. But at the start, for the up the first, there's 800 to 1,000 transaction or customers in there, that it's definitely possible because we're looking at customer spend here. So it's about 1,000 customers that have are spending a lot of money, So, and now this is making the assumption that I haven't messed that up earlier, of course, but that's something to think about. Now we're going to look at stock place data. So what I want looking at here was taking the data and I'm grouping by the stock code, and I'm just doing a distribution of prices. So I just wanted to see how much the prices vary over time, and then just plot out, again, using data table because it gives us a nice plot. We've got all these different stock codes. How many different prices do we see? What's the minimum price? What's the, you know, the quantiles of the prices, the max and the min, and it's 170. So just getting a sense of the various things. We can look at that later. I'm not going to bother with it now because I'm conscious of the time. I'd like to look at distinct price counts. So I'm not necessarily looking at distinct counts here. It's just how often does it appear. Whereas here, I'm actually taking distinct values of the price and then looking at it. So just, you know, we have 6 distinct prices for these stock codes. Let's see what's the highest one. So yeah, so we've got some weird stock codes in here. So this is another great way to check out. Yeah, these are all just nonsense. I'm not even sure what they're in there. What this does suggest we should probably do is filter out these stock codes later, or go back into the data set and figure out what these correspond to and somehow get rid of them. But then we've also got, like, we have a stock code here, which looks like a real one, which is 20685, which is 22 distinct prices. The minimum one is 0. So that's one of the things I'd want to look at. We should probably look at the 0. Is that because it's a return? And see what's going on. Then I'm conscious of the time, so we have a whole load of more exploration to do, which I will probably, I'm going to skip through these parts quickly because I want to wrap it up. I don't want to spend as much as I've kind of belabored the point of exploration. We will be doing more exploration next time, but it'll be slightly more model based. So the total line plot of the spend. So you can see actually, you know, invoice amounts per day coming in. You know, we get quite a bit of a change, and sometimes they go negative. So that's also something we need to check into. Probably do some filtering, some better, more aggressive filtering on like data cleaning, I think, to properly get a sense of these. But we do see the gaps here and here, which are kind of in or around Christmas. So we have these gaps there. But, you know, there is a fair bit of variation. We do kind of see a certain amount of seasonality on the day plots, but we can smooth it out by week. This will give us better values, and we don't have that, you know, those silly daily kind of return based values that are less than 0. But when we look at it by week, you know, we're getting a bit more of a trend here, and we can definitely see there's spikes in or around Christmas. And we do it by month, just kind of flails it out. So one of the reasons why this is kind of useful is this could be useful for taking the data and, you know, like forecasting income, forecasting revenue for the business. It could be useful for that kind of thing as well, and figuring out, you know, how do we account for those different distinct things. The box plot of I've done a box plot. Box plots are amazing. I highly recommend them for everyone. I've looked at the week of the year here in sequential order, and I'm just doing the box plot of transaction sizes on a log scale, so we can see, you know, not a huge amount of difference from one week to the next. We're still kind of seeing all these outliers. We do kind of get, you know, a few bumps towards the end of the year, but nothing too serious, and some negative numbers. So we'll probably have to filter them out as well. I've done that again. The daily purchases. So this is just a transaction date. What I've done here is I'm looking at the total spend, and I'm building a bar of the transactions amount, and then I'm coloring the bar in by total spend just to get a sense. So we can see kind of, when you look at it carefully, you can see things get kind of blue. This isn't a great visualization. I like the approach, but there's just too much on the single plot. So what I think I would do with this is I would take this, and then I would have basically probably a year as separate box plots. That would be a bit more, you know, maybe have 2 side by side, or 3, a full one, and then have 1 year and then the next year. I think that would look a bit better. Refund amounts I was checking as well, because I think they're going to be important, and we're probably going to talk about that a bit more the next time, looking at how much they are. Some of them are quite big, as you can see, like refund amounts of 10,000. So what I've started to do here, and this is probably something we'll investigate a bit longer, there's no data that matches the return to the original invoice. And so there's a couple of different ways we can do it. The very first thing I did was, when I saw a return in the data set, I went through all the data and I just filtered out the ones that have a negative quantity because that's a return. Or sorry, the invoice code started with a C. And then I went back and I took all the previous transaction data less than or equal to that at that date and grouped them in together. So because of the timestamp nature in them, there is a bunch of returns at the start of the data set that do not have any corresponding purchases, which we would expect because, you know, if you start recording today, you get a return tomorrow, but it was a purchase from the week before that we just didn't have time to look at. So, I mean, that's to be kind of expected. But what we're also going to try and do is, because we have all the previous transactions for that customer, for that stock code, we can then start to look, well, does the quantity, is there an exact opposite quantity and price? And if there is, we just make the assumption that that was the purchase. Now, it may be wrong, but at least we can do that. Now, what we find is when we try and do that, though, only about 25% of the returns in the data, about 6,000, actually have matching purchases. I will get to that in a sec. Yes, I have that in here. So this is the days between the purchase and the item transaction and how far. And so one of the things we can see is some of them are like 100 days. I really like the idea of correlating to purchase amount and date, though. That's something I haven't thought of. Yeah, thank you for that. That's a great idea. So yeah, and this is exactly why I wanted to do it. Now I'm conscious of the time, so I'm going to start wrapping it up. But yeah, so there's actually a lot more to be done here, and we haven't gone near a model. And this is the point I'm always trying to make, is that in my experience, it's this kind of stuff is where all the value is, right? It's actually very, very easy these days to build a model. Like it's a couple of lines of scikit-learn or some tidy model stuff in R or Caret or whatever. I don't even know what's used in R these days. I actually know scikit-learn. I'm probably more familiar these days with scikit-learn than any of the machine learning stuff in R, even though I never really use Python. Because, you know, it's very simple to do. This is where all the value is. And this is also more accessible to people. I like the type of purchase. The only problem with that is that we don't have it in the stock code, as far as I can tell. I think this is more of a knickknacks and items rather than clothing, but it's worth looking at. And maybe a little bit of very simple NLP will tease that out. And that's something I haven't even remotely gone near, because the description field is a bit kind of, there's not very many words in it. It's short, kind of, it's a short collection of words. That might be useful, though. It might be worth looking at and doing maybe some kind of word cloud on purchases and stuff and get a set. Actually, that is probably worth doing it. Tokenizing the description and just like producing word clouds by month even might be useful, just to get a sense of, you know, what is being sold and what does this stuff look like. That's it. Yeah, that's a really good idea. So this is, I mean, like I said, this is why I'm doing it. So yeah, so we see that like there's a return. So some of them have very short turns, but then all the rest of them have, you know, 100 days between. So I turned it into days. I did the purchase, I matched it, you know, and then I'm doing a plot. So some of them are over 100 days, which makes me feel that that's not right. I don't know what the return policy is, but usually they're like 90 days or whatever. So I have a good feeling, and this is on a log scale. So all these out here are like a few 100 days. So my gut feeling is that I'm not necessarily matching things up. Also, I've only got about a quarter of the returns have a matching purchase. So my feeling is as well that there might be something in the data where like a return is for 15 items, but rather than being a single purchase, it was like a purchase of 5 and a purchase of 10 previous to that. I'm not really sure how I'm going to do that. What I could potentially do is just take all the transactions that were purchases for that stock code for that customer prior to the return, and then just lop off, like reduce down the amount by that amount until it's all cancelled. But I'd have to match on price. It gets very messy. And this is why, you know, ideally with a proper data set, you would have these properly linked. But, you know, sometimes you just don't get that and you have to make do. All right. Well, thank you. I'm going to stop it there because I've been talking pretty much solidly for 2 hours. And, you know, I've messed up the code a couple of times. But I'm very impressed. I've managed to not scare away 17 of you, or sorry, 15 of you. I'm on twice. But thank you very much for coming. Like I said, I hope this was interesting, and I hope it gave you some sense of you know, how this stuff works in real life. It's not particularly exciting or groundbreaking, or it won't get you a job in Google, even though it should. Like I said, a lot of people talk about, you know, getting like someone with me who works in this stuff for a living for, you know, to do all the modeling, and we'll get some junior people to do all this stuff. That is nonsense. This is what you need the expertise and the skill on, because, you know, you need to understand how data can go wrong, what can mess things up. So in the we're going to continue this on in the next one. I mean, I'm just going to keep talking until literally it's just 2 people on, and probably Neil and Malcolm. By all means, if any of you have any questions, I'm going to push up some code. I'm going to fix some of these things that weren't working earlier into the repo, and I'll push them up later on. The recording is going to go on in a little while. Hopefully it didn't get too messed up by the Docker crash earlier. We have a talk, before I go, absolutely, we do have a talk in, we won't have a workshop next month in March, because we have a speaker, which is brilliant. We have a Owen Hurl is talking about TensorFlow probability. Again, a bit like this one here. He's giving a talk on a topic he wants to learn about. So, and he's a long-time regular at Dublin Data Science normally, and I've been kind of emotionally blackmailing him for a talk for months now. So he's giving us a talk next month. So we'll be back in April with loads of this stuff, things to do. I'll probably have a bit more code written, because I don't want to just keep bombarding you with this kind of exploration stuff. And just try to see, thanks Raphael, it's good to see you, by the way, you know, and figure out what else we can do with this. And then we haven't even looked at, I've used a bit of graph theory to plot this stuff on a graph. It's interesting with, you know, transactions and stock code and plotted on a graph. We've also used association rules to do some basket analysis. And I've a few different kind of other explorations that I'm putting out there, and we'll probably talk about all them that month. In 2 months' time. But thank you for coming along, and I hope to see you in a while, and I hope to see you all at Owen's talk. It's the Wednesday after Paddy's Day. Paddy's Day is falling on a Wednesday this year. So the Wednesday, the 17th of May, 17th of March is Paddy's Day. So we'll be a week after that, it'll be March the 22nd. And yeah, I'm going to leave it there. Thank you for everyone. I can't hang around, unfortunately. So Neil, my apologies. Malcolm, I see you're on. I presume we're good for tomorrow? You're still muted, so that's fine. But other than that, I'm going to stop recording now. And if you have any questions or any comments or anything like that, please just get in touch, and I'll talk to you all soon. Just stop the recording.